previous work we've seen that when we've got the unit circle we've got a couple of things going on. Here's theta and P is the point XY, and we know that the sine of theta is equal to the y coordinate, the cos of theta is equal to the x coordinate, and the tan of theta is equal to y over x, which is equal to sine theta over cos theta, where theta starts out here. So if theta is equal to, say at P1, theta is equal to 0 degrees, and so from that we can work out the sine, cos and tan of 0. So the sine of 0 is equal to the y coordinate. Now what is the y coordinate out here? Now if this is a unit circle of radius 1, then this will be the point 1, 0. So the sine of 0, what is the y coordinate? The y coordinate out there is equal to 0. The cos of 0 degrees, cos is equal to the x coordinate. What is the x coordinate at P1? Is equal to 1. And the tan of 0 degrees is equal to, now 0 degrees is tan of that is equal to the y coordinate over the x coordinate. The y coordinate there is 0 over 1, and 0 divided by 1, you can have 0 on the top, and that'll be just equal to 0. So that's 0 degrees. If we move point P up to here, so this is P2, the coordinate of that point, if it's a unit circle, it will be 0, 1. So at P2, theta is equal to 90 degrees. And so you've got the sine of 90 is equal to, now sine is equal to the y coordinate. What is the y coordinate up there? And that's equal to 1. And the cos of 90 degrees is equal to the x coordinate up here at P1, P2. What's the x coordinate? It would be 0. So the cos of 90 is 0. And the tan of 90 degrees is equal to the y coordinate divided by the x. The y is equal to 1 divided by 0. And divisibility by 0 is undefined. So we've got 90 degrees, sine, cos and tan. We can calculate those. Now you should be in a position now, if we move P3 to there, write down the coordinates, and a fourth one down there, write down the coordinates. So you should be able to, just like we did 30, 60 and 45 before, we got got theta, and we'll have 0, 90, 180, 270. Now 0 degrees is what we call coterminal with 360. One complete revolution is 360. So 0 and 360 you'll think will have exactly the same trig ratio. So we've got sine, cos and tan. So you should be able to fill in those four entities there. We've already got for 0, we've got 0, 1, 0, and for 90 we've all got 1, 0 undefined, and you should be able to do 180 and 270. Well, I've worked in degrees here, but you should be also very familiar with the unit circle in radians. So we've got 0 there, 90 degrees is pi on 2, because pi radians is equal to 180, which is out there, and down here will be 3 pi on 2, and 0 is coterminal with 2 pi. 2 pi is 360, which is one complete revolution. So you might like to just put a little side entity out there, and this will be 0 pi on 2, etc., and fill those in there. So you can now use the unit circle to work out sine, cos and tan of 0, pi on 2, pi, 3 pi on 2, and 2 pi.